Someone else wrote that for me. I love it. Hi, I'm Naomi. I am the head of engineering at CTrees, and today I'm going to be talking about how we move from science data to interactive web maps in our products. So, a little background, CTrees is a nonprofit, and we focus on tracking carbon, forest change, and most of our data sets are high-resolution global time series, and they're currently saved as GeoTIFFs. So we have above-ground biomass at 100 meters going from 2000 to 2025. We have tree cover loss data sets that are 30-meter resolution, degradation data sets for fire logging road for all of the tropics, and that's 5-meter resolution, which is this little web app here that you can see. That's a visualization of it. We have soil carbon data and tree height data that goes all the way to the sub-meter canopy height. So there's a lot of data sets that we have. And this presentation is mostly focused on our finalized data sets to our product, not making the data itself. We have a science team that does most of that, which I do help out. But this is focusing from that final last version of the data to a web app. So the major challenges when dealing with trying to create any type of product from data is data management. So have you ever been personally victimized by data versioning? Trying to find the correct V1 final, V1 final, final, this is really the final one. So as somebody who's worked on the product side and getting those data sets from the scientists, the folder paths get really insane, and so it was very error prone. The other issue that we had with GeoTIFFs is the date, like the actual date of the data, because we're dealing with time series, gets saved inside the file path somewhere, and it's never standardized across our different scientists in our company. We have 15 different scientists. They all have their own way of doing things. And then the other issue with like GeoTIFFs is the metadata. We have categorical data to figure out, like, does one mean deforestation? Does it mean degradation? What does this actually mean? And so we would have files kind of everywhere trying to describe the metadata that's supposed to be associated with the GeoTIFFs that we're dealing with. So when you hand off from like science to product, the engineers don't quite know what the data is, and we have to grab all the information and all the latest versions, and every single time there's a change, we have to go through that whole process again. And then we also had this analysis limitation. So we do a lot of zonal stats for our project. So if we went back at this is the data, and we have some zonal stats associated with it where we grab the degradation over time. To do these zonal stats, each of our scientists had different methods. Some of them were using R, some of them were using Python, some of them were using GDAL command line, some of them opened up QGIS whenever they had to have a different data set. And it wasn't really cloud native compatible. Sometimes we have to download GeoTIFFs, not all of them were saved in COGS, and there was no standardization. So, as our product person, my first solution was to incorporate Icechunk. So Icechunk is a Zarr format that allows you to stack data. So we had a time series of GeoTIFFs, and instead of having a bunch of different files, we could save it in the Icechunk repository, and we could access both the time dimension of it and the spatial dimension. It had versioning embedded into it. The metadata, you could save the information into the metadata, which was great. It was time series datacubes, which is fantastic. So I wasn't dealing with a bunch of different files from everywhere. And with the versioning embedding, I could always just grab latest rather than V1 final, because it would just update automatically. It's completely cloud native. And if you want to hear more about Icechunk tomorrow, Joe over there from Earthmover is giving a Icechunk 2.0 talk at 11:30. Highly recommend going. And then we used Earthmover, which helped create Icechunk. We used their Arraylake for the data catalog so that we could have a single truth of source for all of our data. So when it came to get buy-in from the scientists to actually use this, we were like, how do we do this? And I created a simple pip package using Python. I convinced everyone that, like, okay, if I create a simple way to do this, you can just pip install CTrees kit, and this is mostly for internal use, but anyone can use it. It's a public open package. And it allowed us to have the scientists give us a configuration JSON, which mostly was used to get like the date range and the classification values. So this was so we could go from the folders of GeoTIFFs and put it in our Zarr format. And this is kind of a representation of what it looks like to get like a bunch of GeoTIFFs put it into Arraylake or Icechunk. The Icechunk's the open source version of Arraylake. And you could get all of this information embedded into it, so we could actually have labels like fire logging roads rather than 0, 1, 2, 3. And so I created something called CTrees Kit, which had an implementation of populating these repositories, which would help us easily get to that moment of like being able to use it. So the next step was the analysis. So once we were able to get our data into Icechunk, I needed to have simple functions there to do our zonal stats. So I created something we call the analysis functions, part of CTrees Kit, and these are all using Xarray, so they're all cloud native. They're all very lightweight too. So you can like put these into a Lambda function, which has to be a certain amount of like weight. They can run really quickly, and so I created these functions. These all live on CTrees Kit to clip by geometry, reproject, match, merge multiple classification data sets together. And this is how we get from like a GeoTIFF Zarr format to actual things that we can put into a web app that are charts that we can then map to graphs and things like that. So it's the XR analyzer part of CTrees Kit that exists out there. And so this is kind of what it looked like in the code. It went from having many lines of code to just a few. Our scientists could create this like configuration JSON and then populate their data sets into Zarr, and you could see what it looked like there. And then my favorite part about this is when they ran zonal stats, instead of having columns be 0, 1, 2 to represent what the pixels were, it had the embedded labels, which we could grab from the JSON itself. And so when you grabbed a query, a simple query, you could easily figure out what the values meant. So this is our time series for what our forest cover loss data looks like. And so this is kind of what it looked like before and after. So the first challenges that we had was messy data management, and our solution was Icechunk and using a data management service where you could keep all the data together and grab just the latest version. Instead of using GDAL and R functions, we were able to transfer that to Xarray functions, which they're lightweight. You can put them in a Lambda function on AWS really easily. They allow you to do all the zonal stats. Everything can be cloud native when you grab it too, so you don't have to download anything, which is nice. Our tile servers, Earthmover provides a tile server if you're using their platform, but they also have a way to host your own tile server using xpublish, which is really great. And then I packaged all of the functions into a pip package. So what was really important for this is before we kind of had a one way we would get science data from the scientist. We would do our zonal stats, and then we would have the maps. But with this dynamic setup, we can also have customers give us a shapefile or draw a polygon. And because we have an interactive way to deal with the data on CTrees Kit, we can actually do zonal stats on demand and see the stuff right away. So this is kind of what the web map looks like. Icechunk allows us to grab all the metadata and save everything in a datacube, and then we were able to do the analysis using XR Analyzer. And the reason why we have our own custom analysis functions rather than using some that already exist are because CTrees has some custom analysis that we do to calculate things like biomass, the way that we layer things on top of each other. It was easier to create a pip package that had taking all the scientist information and putting it together. And why is this important? Okay, so one of the reasons why creating a public package for our zonal stats was really important is because we are a data provider, we're a nonprofit data provider, and it's really important to have transparency of how we actually do our calculations. And then having the cloud native platform allows us to deal with data inputs dynamically instead of like going through the process of having a process that where like the user has to go through the scientist to get the data. Now it can happen through the product side and the engineering side, so we don't have to go back and do our whole process every single time we get new updates. Icechunk allows us to scale our data sets. So this allows us, because it's cloud native, multiple people can contribute to it overall. And it allows version control, so there's less of a headache going from science to product. And everything in CTrees Kit can be scaled out using Dask. There is currently a branch on CTrees Kit called Dask CTrees Kit, and those are all scaled out using Dask, so we can process larger data sets on a smaller machine. And what the future looks like is incorporating Icechunk and Zarr formats more on the science to data side and our engineering pipelines, and utilizing Icechunk for our ML pipelines, and adding more functions into CTrees Kit. And that's GitHub. That's me.
Thank you, Melanie. Well, we have plenty of time for questions. Just raise your hand. I will come to you with the mic.
What was part of your, how did you decide on your solution set, like Icechunk, for instance, versus anything else?
Lots of conversations with different people. So Icechunk, I think I had a great conversation with people at Earthmover. Honestly, I went to the virtual CNG conference that was hosted, and coming up with an easy way for data management was really helpful. The fact that it was a time series instead of using, I think one of the issues that we had was we had a data set where the pixel values represented dates, and we were looking at stack versus Zarr. And with the pixel value representing a date, like the stack catalog, you couldn't query it the way that we wanted to. You still had to like have multiple files open if you're just trying to grab like the logging data set. So because most of our data sets are level 3, it just kind of made sense. I also had a good conversation with Matt Hansen when we were debating between whether to use Zarr or stack.
Yeah, so I do wonder if, like, maybe both aren't part of the ultimate solution here. Like, you're using Icechunk, and this seems great for the products that you are creating. But those are pointing back to some sort of authoritative source remote sensing data. And even though, like, you don't want to copy that data, of course, but, like, might a stack catalog make sense in order to record that source data that ultimately is used to go into your products that you're managing in Zarr?
Yeah, I could see that being definitely a use case in the future, and actually getting all of the input data wrangled in a way we could put in a stack catalog. Because I feel like our output data, going from the output to our products, like that's a good use case for Zarr and Icechunk, but the input data, stack would be like, we're looking at doing a Sentinel-2 pipeline where we're looking into the stack input too right now, and like it makes a lot more sense to like have the catalogs that way. I think we're still in a process of cataloging all of our data.
And you're just using public data, right? Like, you don't use commercial.
For Red AI, this one here, this uses planet data, so it's actually not public data. Yeah, okay. But some data we have, we use public data. Most of it's public data.
When you run these on Lambda functions, do you have some kind of upper limit on what will break on using Lambda? Like, how do you bound the size of what you're processing, and do you run into that?
So that's actually why we have a Dask version of CTrees Kit, because we set a certain size limit for our Lambda functions, because Lambda functions can run for 15 minutes. So those are like quick analysis functions. But we realize we're doing like whole global zonal stats. So we've transferred some of that into using Dask functions and scaling out so that we don't run into that limit. So we can break it up into manageable chunks and run it on ECS.
I've got a question myself. This is just on the data part of things. How are you keeping the FAIR principle in terms of repeatability and then reproducibility of your whole pipeline through all the data?
For the engineering side or the ML pipeline?
Yeah. Both.
Both. I should know that, and I don't.
Right.
I'm not that much in the ML side yet.
Hello. Hi there. I'm quite interested in this because I work at Land Information New Zealand, and we don't yet capture data in the form of a time series, but we may start to do so very soon to capture imagery by way of RGBI for the normalized vegetation difference index. This infrastructure that you've presented today, is this something that would be suitable for non-time series datasets as well?
Yes, it is. So because the Zarr allows you to do multi-dimensional. I think the next talk that's here is EOFP, where they're using it for having. So the cool thing about Zarr is if you have a GeoTIFF, it's one resolution. A Zarr, you can technically have multiple dimensions with different resolutions in it. So if you need to store a lot of data into one, you can. The perfect use case in my head is like data that is a time series that is very standardized. There are benefits for both. Yeah, I can't really speak too much. I think stack is a really good one if you're doing like individual images that aren't a standard data cube, right? Like, so the difference between like level 2 and level 3 data is like how it's mosaic together. So I think it's really good for that final data set that's all mosaic together, but if you have a bunch of images that aren't always in the perfect mosaic format, then sometimes things like stack would be probably a better choice.
Do you want more questions, or are we good to close now? Yeah? There's one more in the back there. We have plenty of time.
Thank you. It looks all amazing. I've seen that the pip installation, but you also mentioned that, of course, there's GDAL dependency and so on. So, like, how easy is it to make a Docker image or something like that, which I could run Lambda with?
So we made all of ours. If you take so GDAL has like a mini version. If you're doing something in Docker, right? GDAL has their GDAL mini, slim, something like that. And you could put CTrees kit on top of that. And that worked pretty well. So like it's still light enough. The GDAL main version is really big. There's some functions you can run without GDAL too. That's the other thing is like, if it's doing some type of, the reproject match, it uses a GDAL base because Xarray has, like the Rio Xarray uses that as like a base thing, but it needs like the bare minimum. So if you were to like conda install CTrees kit, it would take the packages that you need without installing all of GDAL. It's the same way as like GeoPandas doesn't install all of GDAL when you do that. Yeah, same type of things. It has the dependencies of like GeoPandas, where you don't need the full GDAL installation, and you can still run it if you're doing it via conda. Via pip, if you're doing it in a conda explorer with the pip, it works too.
Okay, one last one.
Cool, thank you. There was just a lot of mention of stack. Are we talking about the spatial temporal asset catalog?
Yes.
Are you? I'm not too familiar with the Zarr,
Yeah.
but are you using Zarr in replacement of stack? How does that work?
You can use them both together. Right now we are using it as kind of replacement of stack. Well, we're using it as the replacement of GeoTIFFs, and like you could have your time series saved in a bunch of GeoTIFFs and use stack to reference it. Or you can save it in a Zarr format and reference it via Xarray and querying it that way without having to have your assets recorded in that way. So I think they're...
All right, thank you, Naomi. Let's give a big applause and